Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Dini Akmal bin Zainal. My matrix number is CE220124. Today I will explain the question number 1. Okay, let's take a look. Question number 1 is 1. This question, I'm using a homogeneous method to identify first order differential equation. Okay, first we need to move the variable t to the right side and we multiply, and we will get the answer like this. After we get the answer, we substitute x to lambda x and t to lambda t, and we get the answer homogeneous equation with a degree of lambda equal to 2. Okay, for the question A2, we using separating variable method to solve this differential equation. This method involves separating the variable x and y on both sides of the equation and then integrate each side to find the general solution. Okay, first we need to split the variable x and y on both sides of the equation. Then we get in bracket 4y plus 2x dy equal in bracket 1 minus 2y minus x dx, and then we integrate both sides with respect to their respective variables. Then we obtain 2y power of 2 plus xy equal x minus 2y power of 2 minus x power of 2 over 2 plus c, where c is an arbitrary constant of integration. Okay, then we solving for y, then we find y equal in bracket 1 minus x power of 2 over 4 plus c over 2. So the general solution to the differential equation is y equal in bracket 1 minus x power of 2 over 4 plus c over 2, where c is an arbitrary constant of integration. Okay, for the question B, I'm using homogeneous ODE method to solve the question B. First thing we need to do is we move the right side variable xy, then we get 2y power of 2 plus 2x power of 2 over yx. After that, we check the homogeneous equation by substitute x to lambda x and y to lambda y, and we get homogeneous equation with a degree of lambda 2. After that, we substitute y to vx and dy over dx to v plus x dv over dx by product rule. After we substitute, we will get 2 in bracket vx power of 2 plus 2x power of 2 over vx power of 2. We cancel out the x, then we get 2 in bracket v power of 2 plus 1 over v. Next, v in the left side we bring to the right side, and we will get 2v power of 2 plus 2 minus v power of 2 over v. After that, we solve by the method of separation of variable, and we get the answer 1 over 2 ln in bracket v power of 2 plus 2 equal ln in bracket x plus c. We substitute back v equal y over x, and we get the answer square root y power of 2 over x power of 2 plus 2 equal cx. We apply initial condition given x equal 2 and y equal minus 1, and we get c equal 3 over 4. After we get value of c, then we place back the value of c at the general solution, and we get final answer y equal minus x over 4 square root 9x power of 2 minus 32.
Now I will explain simulation question B, line by line. Okay, the first line is to declare a symbolic function y x in bracket. Okay, the second line to compute the derivative of y x in bracket with respect to x and store it in the variable dy. Okay, the third line to define the ODE using the variable dy. And the fourth line, define the initial condition y 2 in bracket equal -1. Okay, the line 5, solve the ODE using the dissolve function and store the solution in y sol x in bracket. Okay, the line 6, simplify the solution y sol x in bracket to get a more readable form. Okay, the line 7, substitute substitute the value x equal x4 times square root 9 times x power of 2 -32 in bracket into the simplified solution y sol x in bracket. Okay, the last line, the final answer is displayed as the output of the last line of code. Okay, for the question C1, this question we using linear ODE to solve it. First thing we need to do is x in the left side we substitute to y to 2y and exponent power of x, and we get dy over dx plus 2y over x equal exponent power of x over x. At here we know the p in bracket x equal 2 over x and q in bracket x equal exponent power of x over x. After that, we're using the integrating formula I equal e power of integrate p in bracket x dx, and we place the p in bracket x, and we get e integrate 3 over x dx, and we integrate and we get x power of 2. And then we're using a formula for q in bracket x is y multiply I equal q in bracket x multiply I dx, and we get y multiply x power of 2 equal integrate exponent power of x multiply x power of 2 dx. Cancel out the x and multiply it, and we get the integrate x exponent power of x dx. We need differentiate by part to integrate, then we get yx power of 2 equal x e power of x negative x power of x plus c. X power of 2 in the left side, we move to the right. After that, we cancel out the x and we get the final answer y equal to exponent x over x minus exponent power of x over x power of 2 plus c over x power of 2. Okay, I will explain simulation question CI line by line. Okay, the first line is SYMS y x in bracket c defines the symbolic function y x in bracket and a symbolic constant c. Okay, second line dy equal diff y in bracket calculates the derivative of y x in bracket and assigns it to dy. Okay, the third line ODE equal x multiply dy plus 2 multiply y equal exponent x in bracket defines the ordinary differential equation x multiply dy plus 2 multiply y equal exponent x in bracket. Okay, the line 4 y sol equal dissolve ODE in bracket solve the differential equation using dissolve and assigns the solution to y sol. Okay, the line 5 y sol equal simplify y sol in bracket simplifies the solution y sol using simplify. Okay, the line 6 y sol equal subs y sol c negative exponent x in bracket, substitute c with negative exponent x in bracket in the solution y sol using subs. Okay, this line 7 y sol equal simplify y sol in bracket simplifies the solution y sol using simplify after substitute. Okay, the line 8 display y sol in bracket display the final solution y sol. For the question C2, this question we're using linear ODE to solve the question. In this question, we know the P in bracket X and Q in bracket X. The P in bracket X is sin t and Q in bracket X is sin t. After that, we're using the integrate formula I equal to e power of integrate P in bracket X dx, and we place the P in bracket X and we get e integrate sin t dt, and we integrate and we get the answer e power of negative cos t. We using formula for Q in bracket X is y multiply I equal Q in bracket X multiply I dx, and we get y in bracket exponent power of negative cos t equal integrate sin t multiply e power of negative cos t dt. Then we get the answer y equal 1 plus ce power of cos t. After that, we apply initial condition that y equal to e and t equal to pi, and we get the value of c is e power of 2 negative e. After we get a value of c, we put value of c on general solution, and we get the final answer y equal to 1 plus in bracket exponent power of 2 negative e power of cos t. And now I will explain simulation CII line by line. Okay, the first line is to define the symbolic function y t in bracket. Okay, the second line, compute the derivative of y t in bracket and store it in the symbolic variable dy. Okay, the third line is to define the ordinary differential equation dy over dt plus 1i multiply sin t in bracket equals sin t in bracket and store it in the symbol variable ODE. Okay, the line 4 is to define the initial condition y pi in bracket equal to exponent 1 in bracket and store it in the symbolic variable con. Okay, the line 5 is to solve the differential equation ODE with the initial condition con using the dissolved function and store the solution in the symbolic function y sol t in bracket. Okay, the line 6 is to simplify the expression for y sol t in bracket. The line 7 is to replace exponent 1i multiply t in bracket in y sol t in bracket with exponent cos t in bracket. The last line is the y sol equal simplify y sol in bracket is to simplify the expression for y sol t in bracket again. Okay, and the last is to display the simplify expression for y sol t in bracket.
Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Wanud Kamil Haziq bin Wanigram. My metric number was CE220132. So today I will explain to you about question 2 ODE project assignment, which is I'm using MATLAB for this for the equation. Okay, first, as you can see, I'm using common sims m to make equation m2 plus 3m minus 10 equal to 0. So to get the solve equation, which is s equal to solve bracket equal and bracket, I will get -5 over 2. So I will using sims a, b, x and a to get equation a equal to be negative 5x plus ae equal to 2x, which is in manual I will do yc equal to ae 2x plus be negative 5x, and then in manual things I will get fx equal to e 2x. Saya juga akan dapat yp sama dengan ce 2x and yp equal to yc, di mana di dalam ni saya menggunakan common sims yx, dan saya juga akan menggunakan common sims c. And untuk differentiate, saya menggunakan common dy equal to div kurungan y, di mana saya akan dapat d equal to dx kali dengan y kurungan x. Okay, saya juga menggunakan common d2y equal to differentiate. Untuk differentiate d2yx, saya menggunakan common d2y equal to differentiate dy. Saya juga menggunakan equation t untuk mendapatkan apa value cx, di mana saya menggunakan c sama dengan kurungan negatif 10 kali y kurungan, macam yang boleh nampak di output tersebut. And saya juga menggunakan common eqn equal to d2y plus dy plus c equal to exponent 2 over x, di mana akan mendapat equation x yang output di sebelah kanan ini, di mana d2 over dx2 sama dengan y kurungan x plus 3 d over dx yx minus 10yx equal to exponent 2x. Itulah output yang akan dapat bila menggunakan common tersebut. Untuk mendapatkan y solve dia adalah saya menggunakan y solve x sama dengan d solve equation, dan juga saya menggunakan cara campur dengan y solve equal to simplify y solve x untuk simplify jawapan tersebut. So saya akan mendapat output yang terakhir ini, di mana di dalam manual saya akan dapat 4cxe 2x tambah 2ce 2x tambah 6cxe 2x tambah 3ce kuasa 2x tolak 10cxe kuasa 2x sama dengan e 2x, di mana itu adalah sebelum saya mensimplify equation tersebut. Selepas saya simplify, saya akan dapat 5ce 2x tambah 10cxe kuasa 2x tolak 10cexe kuasa 2x sama dengan e 2x. So saya akan dapat c adalah 1/5. So yp adalah sama dengan 1/5 se 2x. Itu adalah untuk equation yang kedua, untuk question kedua soalan A. Okay, di sini saya akan sambung explanation saya, di mana question 2 saya buat question 2 soalan B. Okay, yang pertama adalah saya akan buat equation m2 plus 3m equal tolak dengan 10 sama dengan 0, di mana saya akan menggunakan common sims kurungan m, di mana common yang sama saya guna di soalan nombor A. Selepas itu saya akan membuat saya akan menggunakan common s sama dengan solve equation untuk mendapatkan jawapan equation tadi, di mana jawapannya akan keluar negatif 5 dan 2. Jadi saya untuk mengeluarkan output A sama dengan BE negatif 5x plus AE 2x, saya menggunakan common sim x A1 equal to E exponent 2 kuasa 2x, and saya guna differentiate A1x. So dengan ini saya akan untuk mendapatkan jawapan sama dengan 2x E kuasa 2x log 2, saya menggunakan common sims AB untuk mendapatkan value AB. di mana saya membuatkan M equal to eksponen 2x eksponen negatif 5x, dan juga saya membuat 2 punca kuasa eksponen 2x, 5 punca kuasa eksponen negatif 5x, di mana fs dia adalah sama dengan M. Dan macam yang boleh nampak di sebelah, di mana di output saya mendapat output yang sama seperti saya ingin membuat menggunakan common. Dan dalam manual juga saya akan mendapat M sama dengan E2x, E negatif 5x, 2E 2x, dan juga negatif 5E negatif 5x. Dan di mana saya akan mendapat jawapan di dalam manual adalah negatif 7E negatif 3x. Di mana answer tersebut adalah sama seperti dalam output, iaitu answer sama dengan negatif 7E 2x E negatif 5x. Apabila ditolakkan akan menjadi negatif 7E negatif 3x, di mana jawapan tersebut adalah daripada Sims AB dua-dua matrik. Kita menggunakan dua-dua bentuk matrik dua-dua, dan saya akan masukkan equation matrik yang daripada atas tadi, dan akan menjadikan A3 sama dengan 1, di mana answer dia adalah negatif 7 eksponen negatif 3x, di mana M adalah sama dengan Fs eksponen 2x. Dan untuk mendapatkan nilai value dan V adalah step seterusnya, di mana value U saya akan mendapat E2x, E3x, E negatif 5x per 7 tolak A, sama seperti dalam manual. Dan saya juga akan mendapatkan value V, di mana V adalah negatif, saya menggunakan V untuk mendapatkan value V. Saya menggunakan common sims B, Y1, Y2, YY, di mana saya akan campurkan semua equation tersebut di dalam satu equation untuk mendapatkan nilai V, di mana common yang saya gunakan adalah V sama dengan negatif 1/49 punca kuasa eksponen 7x tambah B, di mana saya akan declare Y1 sama dengan Fx, Y2 sama dengan A2. Saya akan juga declare Y sama dengan U kuasa Y1 plus V kuasa Y2, di mana saya akan mendapat jawapan V adalah B tolak E7x per 49. Dan apabila dalam manual saya akan mendapat negatif 1/49 E7x tolak B, di mana jawapannya adalah sama. Dan untuk mendapatkan jawapan akhirnya adalah E negatif kuasa E5x kurungan B tolak E7x per 49 tolak E2x kurungan A tolak E kuasa 2x, E kuasa 3x, E kuasa negatif 5x per 7. Itu adalah jawapan akhir untuk question 2 soalan B. Itu sahaja daripada saya. Terima kasih.
Manual calculation. So let's start. So the system ODE dt I1 is, so here is the negative 10 I1 plus 10 I2 plus 5, the equation 1. And the equation 2 is d over dt I2t equals to negative 20 over 3 I1t plus 98 over 15 I2t plus 10 over 3. So once it's defined, so you will show this equation here, and you will find the general solution once you stimulate. So this will be the general solution. So this is the general solution, as you can see. Yes, this is the general solution for YC. And then for the what I get here is one more thing is the matrix form. So I put here, so once I stimulate, I'll get the matrix form, and I'll get the quality equation from the in eigenvalue form, and then I'll get the eigenvalue 1 and 2, which is 0.4406 and 0.3026. And then once I define the eigenvectors, so I get the eigenvectors for y1, to find the equation for y1 and y2. So once you get the y1, you can substitute and go for equation 2, and then also you can substitute to get the y2. And that's how I can do for the eigenvectors only, because I can't really know how to deal with the stimulation here, but I've got the correct answer in my manual calculation, so I'll show that. So I find the particular integral. So the yp here is ayp plus g equals to c1 matrix c2, and then once you substitute everything, you will get substitute c1 and c2, you get the equation 1 and 2, and then we can find the yp. So the yp here is 1 point. Once you get all the equation, once you substitute 1 to 2, so you get yp 0.50, which is also known as 1 over 2 zeros. You can and see they asked to evaluate the general solution. So you just have to put in yc plus yp, which is c1 c2 and C1 1 matrix 1 0.956 plus C2 1 matrix 1 0.694 plus 0.50. So once you substitute, you will get the YC plus YP equation. And next is D, when for the particular solution, when the Y0 is 1 negative 1. So once you substitute, because y is 0, so you have to substitute its x equals 0, so 0 0 once you substitute, so you'll get the equation. And then yes, once you substitute everything, and then you get your final answer for this. So that's all for me, for my presentation. Thank you very much.